Hi, thanks for coming. This is using security to build with confidence in AWS. My name is Mark Nunnikoven. I worked with Trend Micro for the last 3 years to ensure that Trend's technologies were optimized for the AWS environment. I was fortunate enough to travel around the world and work with our joint clients with AWS to ensure that everybody was able to deploy to the AWS Cloud safely and securely. A lot of really exciting stories out there. It was a really great opportunity for me. I say work for because I recently transitioned to pursue some independent research. I'm now a senior research scientist at OpenDNS, but I am here today on behalf of Trend Micro to talk about securing your deployments in AWS. And since I have no skin in this game, I have no money in the pot, you can rest assured when I tell you that this is not a sales pitch. Right? I'm not even with them at the moment. So this is purely educational, like everything that we've tried to do over the years. And in order to set the stage properly, I want to take a little step back. And this is a list of the major talks that we've done at various AWS events over the last couple years. And you'll get the slides up on the AWS slide share soon enough, so you don't have to write down all the bit.ly links. But these talks actually tell a story. And it's a story of how the cloud has matured, of how we've got a better understanding of how you need to deploy security in the cloud and how you need to deploy effectively in the cloud just in general. But more importantly, we started off introducing the concept of shared responsibility with AWS. So how the security model actually works. So really baby steps into this introduction of this new environment of how IT can change radically. Then in 2013, we've really focused on strategic efforts around security. So a lot of diagrams, a lot of PowerPoints, a lot of talking at a really, really high level, and that was important stuff. But then last year, we really changed it again because it's all good to design and do these architectures, but at the end of the day, that's a very small portion of the life cycle of your systems and deployments. So last year was a really big focus on tactics. So when the wheels meet the road, what do you have to do? How can you leverage the power and functionality in AWS to ensure that your daily operational burden is lessened? How can you automate a lot of your security activities? How can you automate a lot of your deployment activities, right? And that was really exciting stuff. And this year, we're really changing the conversation a bit again. We're going to talk about you. Because one thing that's been fantastic about seeing the evolution of the AWS Cloud is how it's enabled developers and operations and DevOps teams, if you want to throw out a buzzword, if anyone's playing bingo, you already got one, how it enables people who aren't in traditional roles or much smaller teams to deploy these massively scalable applications with huge reach. So this year, it's all about you. That's what we're talking about. So to get there, we need to talk a little bit more about the baseline. So we need to introduce the shared responsibility model for security. This is something that you should all understand. If you don't, you're going to get the 5 to 10 minute version right now, so you will have that understanding. But just to keep you awake, because I know it's post-snack, that's always a difficult time to listen to somebody talk. How many of you know what the shared responsibility model is? Show of hands. That's good. That's great. That means the message is getting out there. What it is a really simple operating concept for how security changes versus a traditional deployment. Very simply named, shared responsibility model. You are sharing the responsibilities for security with AWS. You are a consumer of AWS services. They have some of the burden of securing. You have some of the burden as well. You need to understand where that line is. Conveniently enough, it's like someone actually planned this right down the middle. That's where that line is. Everything on the left is what AWS takes care of. Right? Makes sense. When was the last time you had to make sure that no random stranger walked into an AWS data center? You don't have to. Aaron, you're not allowed to say that. AWS folks take care of that for you. That's part of the service that you get from AWS. They worry about the physical security. They also worry about the infrastructure and the security about the infrastructure. So are the buildings, do they have redundant heating and cooling? Are they in geographically safe locations? Are they properly wired up and connected into the network infrastructure? So we go down the stack a little bit. Is there redundant connections? Are there enough bandwidth to service these things? All these aspects and the security of these aspects are entirely on AWS, and it goes all the way up to the hypervisor layer. Right? So we saw 2 great examples in the last 12 to 18 months of that in action with the hypervisor layer. So I think it was ballpark about 14 months ago. There was the first embargoed bug for Zen that caused a minor outage for some customers as various areas of EC2 and VPC had to be rebooted. Interestingly enough, and a great assurance to us as users of AWS services, very similar situation happened again just recently. Did anybody notice that? No? Couple? That's good. You're on top of the messaging. Did you have to do anything? Yeah? Okay. Bad example. Horrible example. Ignore everything that just happened in the last 10 seconds. But the point was we've got one person in the crowd who noticed that happened this time, and they were able to pull this off with almost zero impact to any customer globally. That's amazing to be able to patch the hypervisor layer at the same level with a critical bug, and almost none of us noticed, right? But there's always one. There's always one guy. So that's how they take care of that infrastructure and the virtualization. They take care of their whole layer. And that's great. And I'll give you the insider secret here. They do a world-class job of that. And that's why we're on their cloud, because we don't have to worry about that. So as a security practitioner or operations or anyone involved with IT, you've got an immediate win going into the AWS Cloud because half the work is done by somebody else. I don't know about you, but I'm a big fan of other people doing work for me. So that leaves us, though. We still have stuff to do. We're not absolved of the security responsibilities. So we have to secure our operating systems. But that's something we're pretty familiar with. A Windows box, a Linux installation, they're the same behavior whether they're in a traditional data center, a physical box, or in the cloud. The software is the same. We know how to lock it down. The hardening guides still apply. You know to restrict account usage. All these things we're familiar with still applies. Same with your apps. Right? You need to make sure you're doing secure app design. You're filtering user input. You're making proper design. You're ensuring that data doesn't flow where it doesn't need to. Right? And that brings us to the data level. So you're ensuring that you're not processing information in places that you don't have to. But these are all concepts that we're familiar with. So again, not a huge burden for us, and we were able to focus more. But what I do want to draw your attention to is the last item in our column, service configuration. Now what that is you need to understand the services and the options that AWS provides to us as consumers. So very easy thing to remember here, the more options you have in a service, the more security responsibility you have in that service. So compare S3, very simple, I have a bucket, I have a policy on that bucket, I have stuff in the bucket, I have policy that applies to my stuff. That's pretty much it, right? There's a couple other config options, that's it. Look at the difference versus VPC. You have to design your networks, your subnets, the routing, how the instances with their security groups live within that design. There's a lot more options. So you have more responsibility, direct responsibility when it comes to a service like VPC. However, the core tenet you need to take away is that you need to understand how these work. Because it's up to you to know what a good decision and a bad decision is in the context of your deployment. And I'll give you a couple very concrete examples. The first one we'll start with is IAM, so Identity and Access Management, right? Fantastic global service, probably the best implementation of access control and identity out there when you compare to other offerings. It actually lets us implement what we call the principle of least privilege, which means don't give a person or an object more rights than they need. So if I'm a user in your network and I only need to access one key or one object that's in S3, only give me rights to access that one thing. Furthermore, only give me rights to read it, because that's all I need to do. I should not have any ability to do anything more. So you can do that very easily with IAM. But the inverse is also true. You can very easily give all of your users complete access to absolutely every service in AWS. Here's my first security tip for you. Don't do that. It's a horrible idea. You should not give everyone in your network admin rights, right? But you can do it if you want to. And that's why you need to understand what the implications of your decision are. Another concrete example, security groups. So these are the control the flow of information in and out of an instance, right? So think of them as the firewall around the instance. You can set up a security group to allow all inbound communication for TCP and UDP over any port from anywhere on the internet. You can do it. It's a horrible idea. There's your second takeaway. That's a horrible idea. Unless you have a very specific use case that requires communication on any port over any protocol from anywhere on the planet, don't set that up as a security group rule. But you can do it if you want to. And if you don't believe me that that's a horrible idea, try it in the management console. You'll see in the management console it warns you no less than 3 times. If you try to do it, it says, do you know what you did there? It's not a good idea. You can override it and say, yeah, I did. I want to do that. Next step of the wizard, it pops up and tells you yet again, did you realize what you did there? You've got a really broad access control or security group policy there. Do you want that? Yeah, I do. I know what I'm doing. I'm smart enough. I can do it. By the time you get to the end, it warns you again and says, okay, you're about to launch with this in place. Are you sure? You can say, yeah, I'm sure. I want it. And it'll do it for you. You'll get nagged again by Trusted Advisor because it is really a bad idea, people. But it's your choice. So it's another solid example of why you need to understand what those options are there. And you're not on your own. There are a lot of great documentation available on the AWS site, and the AWS forums are very, very active, right? So you can get a lot of information there on how you configure your services. So let me ask you a question, wake you up a little bit. How many of you are in a direct full-time security role? Couple? Good. Wow, that's awesome. Okay, normally it's not that many people. Fantastic. So let me ask you, and of course you're not going to give me the answer I want, but that's just the way it goes. I'll ask you anyway. How many of you trust that AWS just does what they're going to say they're going to do, and you just blindly accept that? Right? Can I get a little nod, anything? Yes, no? Of course not. You don't accept it. Security people, we're paranoid. Tinfoil hat is our moniker for a reason, right? Not black hat or white hat, it's tinfoil hat. That's where we go. You need to verify what AWS is doing. This is the last piece of the shared responsibility model. The good news here is they make it very simple. If you see at the bottom, aws.amazon.com/security, also /compliance. If you go to /compliance, you're going to see acronym overkill, logo overload, just a ridiculous amount of certifications. For us as users, the key takeaway from that page is the fact that they've had independent third-party auditors validate that they are holding their end of the bargain up. Okay, and as a user, you can open a support ticket and actually request a copy of the SOC 1 and SOC 2 reports. They are extremely dry, boring reads. If you have a problem with insomnia, that's your solution right there. Try to sit and read through them if you can. You'll get 5 pages in and you're out like a light, guaranteed. But what they give you is actually the evidence that they hold up their end of the bargain, right? And they don't pick like Bob's Auditing of the Bahamas. They have one of the big global auditors come in because it's all reputation based, right? So it's an Ernst & Young, it's a Deloitte, it's a KPMG, it's a recognizable logo saying that AWS is holding up their end of the bargain. So that, in a nutshell, is the shared responsibility model. Everyone's got that as a base? We're good? Nodding is good. Love it. Excellent. So today's talk, getting into the meat of it, we're going to divide it up into 3 sections. We're going to look at a very specific vulnerability. And then we're going to talk about how you respond and then how you actually fix that long term. Okay? And I realize I've mixed my metaphors in the icon. We've got the nice Band-Aid for the repair, and then, or for the respond, and then a wrench for the repair. If you are seeking medical attention and someone grabs both of these items, you have gone to the wrong person. Okay? Should only be one, but it's effective for today's talk nonetheless. So the vulnerability we're going to hang this whole discussion off of is one that you probably recognize, probably going to grumble a bit if you were in an operational role because it caused a lot of headache for us last year. It's shell shock. Everyone familiar with that? Is that a new term for people? No? Lots of nods. People understand shell shock? Okay. So I'll cover it real quick and explain what it is. It was a vulnerability in a command line interpreter called bash. So bash is a very old piece of software. It's a very excellent piece of software in general, with this one massive caveat aside. We've had bash for years, for decades, in fact. And for those of you who use Linux all the time, it's probably your default shell. Right? So it's the default way you interact with your operating system. Those of you on Macs, bash is there as well. If you ever opened up the terminal app, that's what's running when you get your prompt. So it's a very popular, very widely distributed piece of software that runs a key role in our systems. We tell it to do something, it executes commands. Unfortunately, for shell shock, there was a bug. And this is one of the very rare times that I actually show exploit code in a presentation. This is how easy it was to pop something that had shell shock vulnerability. You could actually successfully attack using this sequence. So what bash allows you to do is to link commands together. So you can say, I want to list a directory, and then I want to filter the results of what's in that directory to only look for this item. I only want documents to show up. So you can link these commands in what's called a piping structure. And what this does is this actually makes a fake function that does nothing and then runs an arbitrary command that the attacker wants. So the end result is it's like the attacker is sitting at your command line typing out commands. That should scare you. That's a bad thing to happen, let alone with this little effort, right? This is so bad it was rated 10 out of 10, or 10 and 10, from the National Vulnerability Database. So it means it was 10 because it was ridiculously easy to do, and it was 10 because of the widespread nature of the bug, because bash is everywhere. So I'll show you a demo of how easy this is to exploit. So here we've got a very common contact page, right? It's for Mark's Marvelous Market. Sounds like a good shop. And what it is a very simple contact page. As an attacker, I'm going to go here and I'm going to view the source. Now, for those of you who've been in the industry for a little while, a very common way of doing these pages when it first started out was using a technique called CGI, right? So Computer Gateway Interface, and what that did was took from the web server, it takes the input that the user sends and executes a command on the system. It then returns the results. Any wild guesses as to what actually executes that command underneath the covers? It's bash, right? So this is an easy way to exploit. The attacker looks at our HTML source code and sees the full URL for our CGI script. If you don't think this is still in active use, last time I checked there was about 400,000 first level URLs that actually returned at this. So it's still very, very widespread. And what I did here as an attacker, I used curl, which is a command line web browser, and asked for the password file that lists all the users on this box. Not super useful for me as an attacker, but then I'm getting really mean. And now I'm pulling out the Apache config file and finding out where my private key is for my SSL cert. I'm going to take that one step further. I'm going to run the same command, and now I'm dumping the private key for the SSL cert. So 3 easy commands, one which was actually useless and just for demonstration purposes, and I now have the private certificate for this web server. That's bad. Very, very bad, because the public certificate, shocking, the public key is public. So everybody gets the public key. Now as an attacker, through a very simple, easy command, I have both pieces. I have the public and the private, which means I can now stand between your users and your site, and nobody will know. User comes in, I hand the valid certificate back, I encrypt the traffic, just all nice and easy. I turn around, I hand that back to the server behind me. I'm in the middle seeing absolutely everything that is encrypted. Because it's still encrypted, I'm just decrypting it and then re-encrypting it as it goes. Very simple, very easy to exploit, right? Didn't even take a minute, and we've got the private key. So that's bad. That's why everyone kind of freaked out when this bug was released. Also, as a side note, another reason you should be dropping your certificates on your load balancers. Much, much better place to drop them, operationally as well as security-wise. So, I mentioned this has been in problem for a while. How long of a while? And this is just the fun part, because it's kind of terrifying when you realize how long this vulnerability had been in the wild. It started in 1989. Yeah. For those of you who were around in 1989 and can remember 1989, Poison was charting with Every Rose Has a Thorn. Paula Abdul had 2 hits on the top 10. Crazy, right? For those of you who weren't around, for the younger in the crowd, this was the top cell phone in 1989. Jam-packed full of features. It made calls. That's it. Just made calls. It also weighed in at a clunky 12.3 ounces. For perspective, the current iPhone 6 Plus is half that weight and half that size, and obviously has a huge amount more functionality. So this bug was in production for a terrifyingly long time. So if we actually look at the timeline, you'll see here it was added to the code base in August of '89. It was released to the public roughly a month later. 9,100 days later, we found that it was a problem. That's a new record. It's terrifying. So you'll see in green as well, this was the first time an official patch was released. Then if you look at the timeline, every single entry on this table is something you had to react to. So whether it was more information or actually take an action, it was something that kept your teams up at night, because you're trying to assess the risk that your infrastructure has. So I'll wrap that up into a little easier table, and I apologize to get cut off one. There's actually 5 separate patches that came out for this bug that you had to deploy, and it took you over the course of 2 weeks. So after the initial report, 4 days later, you had your first patch. 9 days after that, you're deploying patch number 2. 4 days after that, you're going for 3. Day after that, it's another patch, and then 2 days later is the final patch. So you had to go through a patching cycle 5 times over the course of 2 weeks while you're trying to consume this information to stop this vulnerability from happening. So let's go jump into how you respond. Day 1, you learn this is a problem. So what you want to do is you want to figure out how you can mitigate the issue. What can you do to stop somebody from attacking you with a simple command like that? Right? So you're looking for quick wins here, a way to sort of stem the bleeding, right? You want to put the Band-Aid on. So the first thing you're going to do is, the first thing we're going to do is take a look at our architecture. Now, as a side note, this is a sample architecture from AWS. If you have not found this page on the AWS site, I highly recommend you go after this talk and look. aws.amazon.com/architecture. They have a whole bunch of these reference architectures for very common design patterns that you want. This one is for web app hosting. They've got them for media streaming, for gaming, for a whole bunch of stuff. Great way to get started to figure out what a best practice design is to get the most out of your deployment in AWS. In our case today, for the purposes of our discussion, we actually can ignore a bunch of this. We don't have to worry about the Route 53 for our DNS or CloudFront for our content delivery or dropping static stuff in S3. We're going to cut this down and worry about just the core. So we've got a world-facing elastic load balancer, so an ELB. We've got a bunch of instances that run our web UI. We've got another load balancer, then a bunch of instances that do our web logic. All right, so very standard N-tier web app. Everyone's probably pretty familiar with that. You're probably running one of those. So we're going to take a look at that, and we're going to push that to a more traditional sort of two-dimensional instead of the isometric. And we're going to look at how traffic flows in that system. In this case, we've got our external load balancer, and we're taking 443, which we assume is HTTPS. And I'll come back to that word assume in a minute. We've got highly available instances that auto-scale across a couple zones. Then we've got our internal same setup, different port, but a load balancer, and then another highly available for our application layer. Very simple design, right? That shouldn't surprise anybody. So let's take a look and see the first thing we need to do to respond. And this is where we're going to go in and we're going to verify our service configuration. So we're going to go in and take a look to make sure that what we've drawn out on the slide and in our architecture diagram is actually what we implemented in AWS, because you could have made a mistake, it happens. So the first thing we're going to do is go into IAM, and we're going to check for our instance roles. So all of our instances have a role when they boot up, and what we're going to do is see the permissions that we have set up for that. So we've got two roles, they're identical at this point, just different names, and we look and we have no actual policy attached. This is awesome, because it has no rights, which means nobody's exploiting that to do anything additional, right? So operationally, we've given ourselves some leeway, because if we need it to go to S3 to get information, we have the instance role attached to these instances right now. It just has no permissions, right? Because you can only assign an instance role when you instantiate a new instance. You can't assign it later, right? So it's a verified identity. So we've checked that. Our instance role is not a risk for us. We've configured it like we want. So now we're going to look at the security groups. And we sorted it very simply. World is the security group around our first load balancer. We're going to see that, and we're going to look. And here we have TCP, HTTPS 443, at least assumed HTTPS, and it's open to the world. That's okay. We have one port, and we're accepting web traffic from the net. That's exactly what we want. So that's a good group. Let's check the second one. So if we start to look, our web server is configured the same way. Sounds right, but it's not, because we want the incoming traffic to come from our load balancer. We don't want the incoming traffic to come from anywhere on the internet, so we need to tighten this up. So what we're going to do is use a feature that AWS has implemented to allow us to actually link a security group to another security group. So instead of using a Cedar IP block, we're actually going to go in and say, okay, 443, that's great. We're going to allow it from the security group in front of it. So in this case, the world security group. So what this has done is said, we're not accepting traffic from anywhere. We're only accepting traffic from members of this other security group. And in our case, we know our load balancer is in that security group. So now we've locked that and we've tightened that up, right? We've restricted the traffic flow in. So that's good. Let's check the next one. The web to app goes around our next load balancer. So we'll see what we've done there, and we'll see if we can tighten that up anymore or if there's any potential risks. Because what we're trying to do is make sure that the roadways we've set up are the only ones in play. We don't want anybody taking shortcuts. And you see here, we've got web to app actually is not bad. It's allowing traffic from 2 internal subnets. But operationally, that's more than we need to put in there. Simply because we can do the same linking and have it look at this security group. Because if we added another subnet at the web server level, the web instance level, we'd have to go in and edit the security group. It's far more effective to simply link the security group. So we'll do that and we'll save it. And then we'll check the last one. We'll look at the app server and we'll see what the security groups look like there. And in this case, we actually did well, I think. And we've got, well, we'll see it update. I'm a little ahead of me. So we'll click on the application server and we'll see what we've done there. But this principle follows along, is that we want to chain. We know we have this nice even flow of traffic coming in, and we want to make sure that our security groups reflect that and that they don't actually stop things. So you see here, this is the last one, and we actually already have it linked. So now we have each of these 4 security groups allowing traffic from the one ahead of it. All right, very simple concept, Very powerful concept as well. So now we're going to check our routing tables and our subnet deployment. We're going to make sure that we don't have any accidental routes set up. We have 2 public subnets. The important thing for us to here is to look at the default. The default's routing out to our internet gateway. That's what we want. But we don't want that on our private subnets. We don't want those private subnets routing out to the gateway. We only want them going forward in the chain. So in this case, you can see that we're actually sinkholing them to a network interface instead of routing them out to the internet gateway. So we're okay on the subnets. So that's good. That's solid. We've made a couple changes to our security groups, and in doing so, we've tightened up the level. And now we'll check our network access control list, our NACLs. These are always the toughest to explain. Essentially what they are is a coarser level of control because they cover the entire subnet. And in this case, we've got traffic is allowed from the rest of our VPC. The rather large port assignments are for ephemeral ports. So there's some good guidance on the AWS documentation about ephemeral ports. And essentially what happens is when you receive a communication on a port, it gets handed off to an ephemeral port so that it can continue to receive communication on the main ports. So we enforce that on the inbound and outbound on our network access control lists. These are essentially copy-paste from the AWS documentations, but it's good to take a look just in case because you might have something that's enabled there that it shouldn't. So that was a quick run through a basic service configuration. If something happens like shell shock, it doesn't take that long to run through that. So we looked through our IAM roles. We looked at our security groups. We did the network segmentation with the subnets and the routing tables, and we looked at the NACLs. All of these are steps in a very nice document that AWS has published called it's a horribly named document, but it's great content. It is the Auditing Security Checklist for the Use of AWS. Super boring, but amazingly important because it is literally a checklist that tells you everything you should be looking at within the service configuration options and making a decision on. So the URL's there. Again, it'll be up on SlideShare, or you could Google for that really long name. Security checklist actually pulls it up, so you don't have to worry about it. But a great document, and it's one you should keep handy because every time you're doing a deployment or a new proof of concept or anything new in AWS, you should be running through this checklist because it'll make sure that you don't miss something silly. So we did that. That's great. We checked our service config. Second part of the response is that we need to make sure that the traffic we're assuming is there is actually the type of traffic we assume. So I said that earlier, and I used that word very much on purpose. Is right now we've allowed TCP 443 from the outside world, and internally we're doing 4433. What runs on 443? I kind of tricked you there. That is the correct default answer. The answer is anything you want. All of the default ports are simply defaults. You can change whatever you want. Right? I can run SSH on any port I want. I can run FTP on any port I want. I can run anything on any port. That's the way the port system works. By default, it is HTTPS. But we need to verify that that is actually the case. So what we're going to do now is deploy a control called intrusion prevention. So intrusion prevention, very simply, looks at all the traffic as it transits the network interface, and it makes a decision based on the rules it knows. So in this case, we're going to verify that it is actually HTTPS. So we're going to look. First packet comes through. It's HTTPS. It's good. It continues on its way. Second one, same deal. It's good. It keeps going. Third one is actually SSH. Don't like it. Intrusion prevention drops it. Very simple concept. Gets a little more advanced. Here's an HTTPS packet, but it actually includes an SQL injection attack. So somebody's trying to put bad input into my app to get extra data out that I don't intend. In this case, intrusion prevention can also help us because it can detect that attack and drop it. So now, by applying this control, we're actually ensuring that the roadways we've set up only have the cars we want on them. Right? Very powerful. It takes us from the assumption that we have HTTPS running across those lanes to actually the verification that it is. So we want to deploy those on all our instances. Okay, so we want to put it in the front and the back, and we want to make sure that it's only running the traffic that we expect. So we're going to take a quick video, and we're going to see what that looks like. So here we've got our same attacker. We're going to flip over into our control, and in this case, we're going to be using deep security from Trend Micro. And we're going to actually go in and apply a rule in the intrusion prevention that looks for that exploit code for shell shock. So it's going to look for the pattern that has that pipe and then an arbitrary attack. So a fake function and then a pipe. And it knows what that looks like in all its different permutations. And we're going to actually monitor the network traffic and drop that packet anytime we see it. So we're going to select our rule from the list, and we're going to apply it. It's going to deploy that policy out to the agent that's running on all of our instances, and it's now going to be monitoring for that specific set of patterns. So once that's deployed, we're going to flip back and we're going to change hats. We're going to take off our tinfoil hat, put it back on our black hat, and we're going to run the same attack. So we're quite literally, same session. Now we're going to run the same command, and we're going to see what the results are. And you see the results are nothing. It's an empty reply from the server. The server reset the connection. Do it again just to make sure. And what this is now, the attack is the same, but the difference is there's an intrusion prevention control wrapped around the network interface on our instances. And anytime it sees that attack come through, it recognizes that pattern and it resets the connection. So in essence, what we've done is we've virtually patched that instance. We haven't actually fixed the problem, but we've stopped anybody from being able to take advantage of it. And that's excellent. For us right now, what that does is it buys us time. Because now we can go through the process of actually fixing the problem. So for IPS, you want to make a couple quick things. You want to make sure that you've got all your instances covered. You want to make sure that you've got workload appropriate rules. So the advantage of having host-based intrusion prevention is that you can have rules that only apply to what that instance is doing. So unlike a data center IPS where you have to have protection for everything in the data center, here you can have a highly optimized rule set. And of course you want to manage it all centrally. You don't want to manage 100 different IPSs, you only want to manage by group or by policy layer. So once we've got that in place, now we can actually go to fixing the problem. So we bought ourselves time, we've fixed it with the Band-Aid, now we can take out the wrench, mix our metaphors, and fix the problem. So we've got our same deployment, and what we're going to do is we're going to look at how we actually make these instances. Okay? So best practice for having our instances, we should have an AMI somewhere, right? What we're going to do is we're going to look at how we actually make that AMI and how we can leverage some best development practices to actually increase our security posture. Because that's the big win here, is that a good security practice has a huge amount of overlap with a good development practice. In fact, they're almost exactly the same thing. And that's excellent. So for a lot of people who aren't in full-time security roles, it can be really intimidating to look at the amount of effort you have to do for security, right? But if you pick the right security tool set, and with the advantage of the fact that everything in AWS is an API, you can automate a lot of that workload. And a lot of that workload is stuff you should be doing anyway. So for an AMI, this is the proper way to bake one. And I say that very specifically because this integrates very nicely with a lot of continuous development practices, a lot of the great services that were announced at last reInvent. So a lot of the overall pipeline, but not the actual pipeline service. I find that confusing, but the code flow. So you're thinking code deploy, config, the pipeline service. All these things help you do this properly. Also OpsWorks, or if you're with a community tool, something like Chef or Puppet or Ansible. So you get an AMI, you instantiate something new, you configure it. Pretty straightforward, right? Give me Amazon Linux, then you start to run your configuration. Then you bake your AMI. Not rocket science yet. Then you instantiate a new AMI, or a new instance off of that AMI. So you built some, you launched up Amazon Linux, you made a whole bunch of configurations, you configured Apache, set up all your normal, your application, then you bake your AMI, you instantiate it, you test it, you automate your tests, right? It's all automatic. That's the goal. That's what you should be shooting for. You should not have a human involved in this process other than to say go. Once it passes the tests, you destroy it. So I'll walk that through in a little more robust manner. We're going to have our AMI, and we're have a bunch of instances. These ones are in production, and we know there's an issue. So in this case, there's a bash vulnerability that we need to patch. We are going to leave these. We've already mitigated the issue by putting IPS in front, so we're going to leave those instances in production because we know the IPS is going to protect us from that exploit. We're going to call these instances the blue group. Okay? They're in production, they're continuing to serve your users. Very important. We're going to take an isolated test space, whether that's a VPC subnet, a new VPC, a different account. Doesn't really matter as long as you've got the access to the AMI. We're going to instantiate a new instance off our main AMI. We're then going to apply the patch. So this is something we had to do 5 times for shell shock. We're going to apply the patch, then we're going to bake a new AMI. We're going to call that AMI v2. Okay, this one has the patch. We're then going to instantiate another instance. This one comes off of v2 though, so this one should be patched, right? So here he comes, and now we've got a good thing to test. So now we're going to run our automated test suite. And this is not just testing to see if the vulnerability is fixed. This is testing to see if your application still works, right? Did we break anything incidentally? Because it's automated, you can go through the whole regression testing. Of course, because we're awesome, it passes, right? It always passes first time. Yeah? Of course it does. Let's pretend it passed first time, but it's automated, so we can test this a lot. So it passed, that great. Now we go back up to production. We take AMI v2. We're going to now instantiate a bunch of instances. We're going to call them green. We're going to run a whole bunch more tests because they're automated and we can. And they all pass every time. Yes, you can tell I've had tests fail before, right? So they pass. This is great. We know they're ready for workload. But right now our ELB is sending all the traffic to the blue because they're still in production. They're protected by the IPS. What we're going to do is once we verify that the green instances are online and active, we're going to connect them to the ELB, and we're going to slowly drain the connection pool from the blue, and we're going to have all of our traffic and our users over to the green, and we're going to then retire all the blue. So here what we've gone through is an entirely automated cycle where we have zero downtime, yet we've deployed a patch and verified it's working and then have restored production. Very easy to do because it's all API calls, right? To try to do this in a traditional deployment, say 10 years ago, you had to worry about capacity. Do I have enough boxes? Do I have to rack it? All this type of thing was way too much effort. In AWS, it's simple. It's fast. It's easy. It's all automated. The only thing a human should have to do is say, yeah, I have something new. I need to test it. Then you push out the patch through whichever service you're choosing, and off you go. So that's how a blue-green deployment works, or a green-blue deployment, depending on how you want to call it. But very simple, very powerful technique. Key thing here, zero downtime, right? Patch on the fly, zero downtime. Amazing. So we've done that. That's great. But the reality is, as much as we like to say that we know what our current production deployment looks like, things change over time, right? Things drift. You get the cache fills up, some temp files are in there. There are changes over time that happen to these. So we want to make sure that we know what's going on. So as these changes happen over time, some of them are expected. Sometimes they're not. Because regardless of the controls we put up in place with something like intrusion prevention, we still, paranoid tinfoil hats, want to make sure that we're monitoring. Because every once in a while, something bad still slips through. So integrity monitoring is a control that we're going to deploy. And what that does is it looks for changes on our instances. And when it finds something that meets its rule set that looks weird, it's going to raise an alert. Right? So it's going to ignore, say, the cache, but it's going to look at your source code. And if something changes in the source code, it's going to raise an alert. Now sometimes that's okay because you just deployed a new version. But if you're following blue-green deployments, that should never be okay because you know you're never changing code or configuration on a running instance. You're making those changes and building new instances. So integrity monitoring is a great way to catch if somebody's not following your best practices for development. It's also a great way to figure out if an attacker has actually made it through the defenses you've set up and has made a change. So we're going to see that in this case. And we're going to go back to shell shock again, and we're going to pretend for a second that somebody ignored our great advice about intrusion prevention. And we're going to deploy a rule that's monitoring for SSH key material. Okay? We go back, we put on our black hat. What I'm going to do, I have a couple choices when I attack you. I could have popped your private key. I could also have done this, and this is really evil. I'm pulling the authorized SSH keys from the instance, and I'm seeing who's authorized. My next shell shock attack, I'm replacing that list of authorized keys with my own and removing yours. I have now stolen your instance. That's bad. That's very bad. But because we have integrity monitoring, we actually got an alert that told us that those authorized key file had changed. Right? So that's another way for us, another safety net for us to know if there's a change on our instance. Again, very, very powerful control. So when you're responding, there's a couple things you want to make sure you're doing. Right? You have those two phases. You've got the Band-Aid and then the wrench. When it comes to the Band-Aid, you want to make sure that you're reviewing your configuration. So you're going through the security for AWS checklist, and you're making sure that your IAM roles don't have any more permissions than they need to. You're making sure that your security groups are locked down as tightly as you can. You're making sure that your subnets are routing properly, that you don't have stuff going out to the internet that you're not expecting, that you don't have unexpected peering between different things. You're reviewing your network access control lists to make sure that they're not too broad. You're doing all that ideally in an automated fashion as well. Then you're applying a mitigating or compensating control, so a mitigation. You're putting something in there to stem the bleeding, right? In this case, you're doing intrusion prevention. Because what intrusion prevention does is it verifies that the traffic you're expecting is actually what you're expecting. So it's going to verify that that format is actually HTTPS. It's going to take it a step further, and it's actually going to look for active attacks in those packets as well. Very powerful control. Then you get to the repair phase. So you stem the bleeding, you put the Band-Aid on, you bought yourself time. Now you're going to look to actually fix the problem. You're going to patch the vulnerability in a new AMI, right? You're going to do a blue-green deployment. You're not going to touch your production. So for me, and this tends to shock a lot of people, but I like instances in production that nobody can access. They're beautiful, isolated little things doing their job. Because anytime I need new ones or need to make a new change, I go through that whole cycle. I go through that blue-green cycle. Because now I can be guaranteed that if any change happens in production, it's bad. It's nice to boil it down to a black and white decision. If that change happened on an existing instance, it's bad. Why? Because we never make changes on those instances. We never even log into them. So you can avoid that SSH key attack by simply not allowing anybody to ever SSH in. It's a different way of thinking, but it's an extremely powerful way, and it's enabled because everything in AWS is an API call away. Your security tool set should be very similar. It should be programmatic. You should be able to program and deploy all hands off. So in that case, we're doing those blue-green deployments. We're patching vulnerabilities in our new AMIs. We're also leveraging integrity monitoring because that's telling us of any change on those instances in production. If there is a change, we're going to get notified. We're monitoring key areas like our source code, like our application source code, like our data. And anytime there's a change there, we're raising an alert and we're reacting appropriately, right? So layers of controls, layers of protection for us. The big key, if you haven't figured it out yet, is every single thing should be automated. So I'm a developer at heart. I like to have the computer do stuff for me, right? I enjoy stuff, just not computery stuff. If a computer can check that all my AMIs are the right version, why not? I don't want to sit there combing through things. I should automate it. I don't want to log in to 100 instances to deploy a patch. It should be automated. It should be a script. There are tools available from AWS. There are tools available in the community. There's a lot of expertise out there. Your security tool set should be able to fit into this new paradigm that everything is automated. If it isn't, time to look for a new set of security tools. So I will show you a little video here, and I'll queue it up for you, and then we'll do a little Q&A after. The important thing here is, for those of you that aren't in full-time security roles, to realize that this effort, was anything in here shocking, besides the fact of how easy it is to steal certificate keys? Right? Nothing was shocking. So doing those sort of blue-green deployments, from a development perspective, that's continuous integration, right? That can literally be run from your build server, from like a Jenkins, right? This is all just good development practice. But the beauty of it is that we all just talked about securing our deployments, right? There's no additional effort here other than being aware that your security tools should go along for the ride in your normal development best practices, right? That's a huge takeaway, because at the end of the day, your users trust you. They trust you with their data, right? Whatever your service is, whatever vertical you're in, your users give you their data, right? Or they pay you to hold their data. The last thing you want to do is end up on the front page from a security breach or from a misconfiguration and betray that trust of a user. Because reputation tends to be everything when it comes to these deployments, right? There are a lot of competitors. None of us are in a field or in an area where we don't have a competitor. And if you make a misstep, that's a gain for your competitor. If you're in a field with no competitor, you're either in a field that doesn't exist, or I want to talk to you because that's cool. So it's important to hold up that trust for the users. And that's why I want to show you this, and then we'll do some Q&A afterwards.
cloud powers your apps, and your apps are an integral part of your users' lives. They trust their data to you. Be sure you're honoring that trust by securing your cloud deployments.
So, key takeaway, right? Your users trust you. You need to honor that trust, but it's not that hard, right? If you pick the right security tool set, it integrates already with your development flow, with what you're already doing. Yes, there's a little additional effort to monitor and to be aware of what's going on, but it's not a completely different set of skills. So if you're not a full-time security person, don't let that dissuade you, right? Little effort, little education, picking the right tool set, making sure you're following best practices for deployments and for coding and for developing, you can have better security by leveraging the power in the AWS Cloud. Thank you. We'll do a little Q&A. So if you do have a question, there are microphones in the middle. So question?
Yeah, I have a quick question. How do you, how can you detect non-travel patterns in real time? Because in your case study, a lot of patterns that are non-patterns are sort of, SQL injection or shell shock. We know what the root cause is, so you can detect in real time. Those are travel patterns. But virtually there are unlimited number of patterns. Also, a lot of patterns we don't know. How can we detect it in real time?
Sure.
That's like looks like a high velocity big data problem,
Yes.
I'm not sure what's your approach right there.
Absolutely, good question. So just to summarize, basically the question was, what we saw in the intrusion prevention system was capturing a known attack. So we knew what a shell shock attack looked like. We knew what a SQL injection attack looked like. How do we detect abnormal patterns or heuristics on the fly to figure out that that's a bad thing? And the answer for that is that it's a very difficult problem to tackle, which is why in security we never rely on one thing. Right? So what you want to do is you want to have multiple layers of controls because you realize no one control is going to catch everything. So that's why we looked at 2 controls today. So if you can't detect what you don't know yet through the IPS engine, and though there are some interesting academic papers on doing those type of dynamic real-time analysis, that's why we deployed the integrity monitoring. Because we go, you know what, we're not going to catch absolutely everything with the IPS, we're going to catch a lot, we're going to catch what we know about, but that's why we want to make sure that if anybody makes a change to our application source code or to our deployed binaries or to our key data, that we know so that we can react. So the answer is you can't always catch everything, regardless of how good the technology is, which is why you want another control in place or a series of controls that can help ensure that the key asset that you're trying to protect, which is your data, stays secure, or at least you're aware of what's going on. Yeah?
Thank you. In the architecture that you showed with the load balancer in front of the web layer and another load balancer in front of the app layer, you deployed IPS at the web and the application layer.
Yep.
And it's the same IPS engine, correct?
Yes.
Why would you, is that overkill at the application layer? Why wouldn't you just do that at the web layer?
I would do it at both because A, I'm paranoid with my tinfoil hat, but also because the difference with the host-based intrusion prevention is I'm going to have different rule sets running on each of them. So for the web, I'm going to have everything around HTTP, HTTPS, the SQL injections, all that type of stuff. And in the back end, I'm going to have additional rule sets. So depending what I'm running for my business application layer, so if I'm doing like WebSphere there, or if I've got some custom stuff that I've written, I'm going to apply rules that are appropriate to that and exploit there. So you can customize your rules to get multiple layers.
Thank you.
Yeah, no problem.
Where do you terminate a SSL connection? You mentioned that you'd rather do it on Elastic Balancer, which you didn't do, and that would contradict the way you mitigated the attack, actually, I believe. Then you said that it's Amazon responsibility to handle security of the network, and I wonder if the last piece of the connection, which was pure HTTP, is protected by Amazon, and where's the boundary where it's Amazon work to protect this connection from any sort of
yeah, great question. So the question was 2 parts. First was SSL termination. So I prefer on the load balancers simply because for certificate management, it's far easier operationally because you've dropped your cert in one place rather than having a copy of your cert absolutely on every instance. Easier to roll over, easier to maintain. Also, it offloads the processing off to the ELBs as opposed to absorbing that as a computational cost on your instances. As to whether that would actually mitigate the attack, it wouldn't, because what the shell shock vulnerability is not actually attacking HTTPS. What it was doing is it's using the transport and attacking the application level. And that sort of leads into your next question, which where the line is between AWS and you, the user. Anything at the application level, so layer 7 in the OSI stack, is always going to be on you. So AWS does have operational security, and they do run it within their infrastructure, but it's up to you. That's firmly in your area to ensure that you're protecting your apps and your data and your OS running on. And I see you disagree, but we can take that offline. It's for sure. Last question?
I just wanted to, hear your thoughts about adding, like things, like IPS or maybe open source OSIC into elastic beanstalk instances to try and take advantage of auto scaling. So I'm just wondering, of course, there is times when Amazon is going to try and update those instances that you started with. So I just want to know what your thoughts or experiences with those kind of
Sure.
situations.
So the question was integrating those types of controls into an elastic beanstalk config and deployment. And I love beanstalk. It's great, especially from the IDEs if you're running from Eclipse or Visual Studio to be able to put there. I like deploying those additional controls, and I like to roll my instances quite a bit, but it depends on being task specific. Specifically to OSEC, Trend is a big fan of OSEC. We've supported the project for a number of years. Deep Security is somewhat rules compatible with OSEC, in fact, and then they just layer additional controls on top of it. So OSEC purely does the integrity monitoring piece, whereas Deep Security does that as well as the intrusion prevention, anti-malware, and a whole bunch of other stuff. The more controls, the better, I tend to find, with the caveat that you don't want to increase the amount of operational burden that you're putting in place. So for every new control or new solution you deploy, you have to run it, right? That's the unfortunate reality. You have to run it, and for security tools, normally that means reacting to the alerts and information that it generates. So you want to make sure that you're getting the biggest bang for your buck, but there's a lot of great open source tools out there, and not just the couple you mentioned. Perfect, thank you. Any more questions? Yeah, one more.
I see Trend Micro, when you show the demo and everything is host-based IPS.
Yeah.
What is the approach for hybrid with network IPS and host-based? Can Trend Micro support that?
Yeah, there's no direct integrations, but as far as a logical deployment, what you can do is have the broader filtering with the network level, because it's covering everything in the network, and then have application or workload specific sitting on the instances. The challenge you get in general with network level IPS in an area like AWS is the math tends not to add up. You have to scale your network IPS level layer in conjunction with the application layer to support the traffic, and you're basically double paying. Whereas if you go with host-based, you have a much nicer linear scale, because every time an instance is deployed, it has all its security sitting on the instance itself.
So on your slide, I see on the shared
Responsibility?
responsibility, the left side is AWS, which protects your infrastructure.
Yep.
Then does it have a network IPS then?
If they do, they don't tell us.
Okay.
It'd be a better question for AWS, and they've got a great team at the booth here. But regardless of, from the context of that you would, as a consumer of AWS services, be concerned about IPS, it's up to you to deploy. So they have a top-notch security team worrying about their half of the model, but as far as your applications and defending your data from an intrusion prevention perspective, it's entirely on you.
All right. Thank you.
Perfect, thank you. Question? Yeah, I think we can squeeze one in.
Okay, just want to know about message encryption.
Yep, in general?
Yeah, I mean, how they're implementing it here. I know the SSL offloading is happening at the HTTPS, the load balancer level, right?
Ideally, that's where I prefer to deploy it and sort of offload it, but individual message encryption?
Yeah.
So specific to what we talked about today, we didn't really tackle it, but I can talk to you a bit offline about what's going on there.
Sure.
Excellent. Perfect. Thank you very much.